Okay, so let's we'll start talking. We'll continue talking about those air pollutant issues. So we'll now focus on ozone. So it's a there are two types of ozone we are talking about. One is the ground level ozone, and also like we have tropospheric ozone and also ozone in stratosphere. So there are if you look at in terms of ozone as an air pollutant. So as you can see, there is a dangerous ground level ozone which we worry about. So this is a dangerous ground level ozone that we worry about. That's called tropospheric ozone, and then in the stratosphere, actually that's a protective ozone layer. So we have to save that ozone as well. So this is the ozone in the low zone of in our atmosphere. So in the ground level ozone, it is actually cause a pollution, heat plus sunlight. So that's really creates ozone. So ground level ozone is not emitted directly into the air, but it is created by chemical reaction between oxides of nitrogen and volatile organic carbon. So when we have this ground level ozone, it is because of the chemical reaction between the NOx, which is emitted as a primary air pollutant, plus volatile organic carbon. So you saw that in, if you remember from that first video in term for air pollution, we had that primary air pollutant and secondary air pollutant. In primary air pollutant, we had NOx and VOCs both. So when they react together, they produce ozone. This happens when pollutants emitted by cars, power plants, industrial boilers, refineries, chemical plants, other sources, they react in presence of sunlight. Ozone is most likely to reach unhealthy level in the hot sunny days in urban environment, but can also reach high levels during the winter months. So it can also be transported long distance from the urban area to the rural area. So in rural areas also we can experience high concentration as well. So that's the reason of worry in terms of ozone in terms of the ground level ozone. Now, if you look at the ozone in the atmosphere, this is ozone concentration. The ground level is our tropospheric, and then we have the stratospheric ozone. So this ground level ozone, we don't want ozone in the ground level, but we are seeing an increase in the ground level ozone, as you can see the red line. So that's where we have, this is the altitude in miles. This is altitude, sorry. That's our altitude in miles, and then that's in kilometers. So and that's the ozone concentration, and that's we are looking at ozone in the atmosphere. So you can see this red stuff in here. So that's increase in ozone because of the pollution, and we are talking about tropospheric ozone. So we want the tropospheric ozone to be towards 0. We don't want ozone to be present here. And in the stratospheric ozone, we want the ozone to be there because that acts as it acts as preventing those UV lights from coming to us. So from the UV light from the sun, it prevents that from reaching us. So we need a high ozone layer on stratospheric ozone. We need it in that particular zone. So that's important. So that's it's kind of, you can think about similar to your like some other pollutants. And when the ozone is present and other pollutants are present, we also create photochemical smog. Photochemical smog is when you have UV from the sun. So now if the atmosphere, if the upper layer of the atmosphere, we don't have ozone present. So now that we will have the UV light getting into the earth. So when the UV light comes into the earth, it will react with nitrogen oxide in the atmosphere, and so you will start seeing photochemical smog, and you see as a brown haze, and that is most prominent during the mornings and afternoon, especially in densely populated warm cities. So you have photochemical smog, you have nitrogen oxide, you have solar radiation. So as you can see in the in this diagram over here, we have the solar radiation. So we have the UV coming in, we have nitrogen dioxide present. So that will used with the H2O, like in the atmospheric water also present. So you will have HNO3 acid. You have with the UV and all, it starts producing aldehydes and all that, certain hydrocarbons, then ozone, and because of the molecular oxygen present as well. So, molecular oxygen plus atomic oxygen coming from this NO2 getting, because of the photochemical reaction, NO2 will get divided into NO and oxygen. So, oxygen will react with oxygen to produce ozone. Now, ozone and with all these organic stuff will together will call this photochemical smog, and then you have the problem, visibility problem, that you see the brown haze and all that in the morning and the evening time, morning and the afternoon times. Let's clean this up. So, what is the effect on plant? The ground level ozone causes more damage to plant than all the other air pollutants combined. So, ground level ozone is creating more damage. Ozone leaves through the stomata during normal gas exchange as a strong oxidant. Ozone is a strong oxidant. It will cause several types of symptoms, including chlorosis, and you have necrosis happening. High concentration of ozone causes plants to close their stomata, slowing down photosynthesis. Prolonged exposure reduces health and productivity of crops. High concentration can affect soil fertility. Plants that are exposed to high ozone metabolizes less carbon dioxide. So, less carbon is available to the soil, and fewer soil microbes can grow and thrive. So, that's it creates a lot of issues there. Smog, which is formed because of ozone and NO present, it's a ozone. The main ingredient in the smog is one of the most widespread air pollutant and among the most dangerous. It's how ozone forms. We already talked about. You have oxygen in the atmosphere. You have nitric oxide, NO, which is a byproduct of combustion. You have the sunlight, which breaks the nitric oxide. So, you have NO2 gets to NO plus oxygen. Now, oxygen free with the atmospheric oxygen now you will have 3 oxygen together, and that is your ozone. So, it creates burning, eye sensation, headache, irritation in mucous membrane, shortness of breath, wheezing, coughing, asthma attack, chest pain when you increase when you have inhaled high concentration, and then increases the risk of respiratory disease, pulmonary inflammation, increased risk of heart attacks. So, in US in parts per billion, if you look at parts, they had in 1997 to 2008 the limit was 84. Now, in 2008 they bring it down to 75, and in the new EPA proposal they are even trying to bring it down to 70, between 60 to 70. That is what they are debating in terms of probably either 60 or 70 would be the smog concentration. So, from time to time we have been seeing organizations which is coming up, like looking at different aspects. So, this is long range transboundary air pollution. It is a convention which was done, which actually the goal was to attempt to protect the intention was to protect the human environment against air pollution and to gradually reduce and prevent air pollution. So, it is a European, it was implemented by European Monitoring and Evaluation Program, and part of the UN ECE, which is the Economic Commissions for Europe. The convention opened in 1979, and then it came into efforts in 1983. So, overall what it did is the countries which ratified it, they committed themselves to gradually prevent and reduce the discharge of air pollutants into the atmosphere. So, there are different goals of this convention, which again we will talk about that in the class in more detail. The Council decision concludes that convention on behalf of EU. All member states were parties of that convention as well. Then we always talk about Montreal Protocol. That is another which talks about this is substance on ozone layer, and Montreal Protocol on substance that deplete the ozone layer is a landmark actually. It is a multilateral environmental agreement. It regulates the production and consumption of nearly 100 man-made chemicals which are known as ozone depleting substances, which is creating ozone depletion in the stratospheric ozone layer. So, that is what in the stratospheric ozone layer the depletion is happening. So, the Earth's protective shield that protects. So, we have a protective. If you look at the Earth, on top of Earth, we have a protective shield here. So, if this is our Earth, we have a protective shield. That ozone layer in the protective shield is getting damaged because of these 100 chemicals. So, there is a Montreal Protocol is suggesting that let us try to control the release of these 100 chemicals. So, that is what it is all about. So, it is adopted on 15 September 1987, and the protocol is to date the only UN treaty which has been ratified by every country on earth, all 198 UN member states. So, you can think about that is actually only one stuff which is has been ratified by all these countries. So, what is ozone depletion means? Actually gradual thinning of ozone, Earth's ozone's layer in the upper atmosphere, which we talked about, because the release of the chemical compound. These chemical compounds are mostly gaseous, chlorine and bromine from industry and other human activities. So, thinning is most pronounced in the polar region, especially over Antarctica. We are seeing more. So, when the thinning, what happens is, if you have thin layer of ozone, UV can get into. So, it increases the amount of UV getting into the Earth's surface, and if the UV is getting into the Earth's surface, that leads to the skin cancer, eye cataract, genetic and immune system damage. So, that is why we do not want that ozone layer to be compromised. So, we want that ozone protective layer to be there. So, Montreal Protocol, which we saw that the first international agreement, halt the production and use of ozone depleting substance. So, as a result of ozone layer is expected to recover over time. So, that is what our goal is, to try to recover. So, if you look at the stratospheric ozone depletion, you have the CFC molecules, the chlorofluorocarbons, which we talked about. UV causes a chlorine atom to break away from CFC molecules. So, when the CFC molecules gets into the atmosphere, so UV is actually what the UV does, it breaks away one of these chlorine. As you can see, there is a carbon, there is a fluorine, and there are 3 chlorines. So, one of the chlorine gets broken away because of the UV in the upper atmosphere. Then the chlorine reacts with that ozone, and they produce chlorine monoxide plus oxygen molecule. Now, oxygen molecule, a free oxygen form hits the CLO. So, CLO, which is present at the fixed oxygen, hits the chlorine monoxide. The result is now you have another free chlorine. Now, once you have free chlorine, again it will react with ozone, and the cycle continue. So, and that, because since it is reacting with ozone, so it is it's reducing the ozone layer. So, ozone is getting eaten up in the stratosphere because of the release of the CFC molecule. The CFC molecules is the chlorofluorocarbon. It is one of the coolant, you can say. It was used for different applications. It was used for refrigerators and all that. So, for that's one of the major, and this is one example. There are several other compounds as well. So, the goal is to kind of reduce the use of CFC, so that less CFC will get into the atmosphere, and if the CFCs are not there in the atmosphere, it will not have the ozone layer depletion. So that is what the whole mechanism in which it works. So, our goal is, so we saw that already. We want lower smoke zone. We do not want ozone in the tropospheric ozone. We do want ozone in the stratospheric layer. So, contains 10% of atmospheric ozone is the tropospheric, harmful in fact, toxic effects on humans and vegetation. Current we see the high surface ozone in urban and rural areas. Now, on the stratospheric ozone, we have 90% is there. It is a beneficial role. It acts as a primary UV radiation shield. The current issue is the long term global downward trends, and especially over the springtime Antarctica ozone hole each year. So, that's an issue. So, we have to try to contain we have to maintain the stratospheric ozone layer and reduce the tropospheric ozone release. So, in the South Pole is a very large land mass, Antarctica, that is completely surrounded by ocean. So, meteorological condition allows formation of winter in very cold region over Antarctica. So, it is a strong winds are happening there as well. So, low stratospheric temperature lead to formation of clouds. They are responsible for chemical chains that promote production of chemically active chlorine and bromine. This chlorine and bromine activation leads to rapid ozone loss when sunlight returns to Antarctica in September, October. So, that is and which results in ozone hole. So, we have to That's we are worried about that. So, as you can see, the view of total ozone over Antarctica pole from October 2018, the purple and the blue colors are where there is a least ozone. So, you can see the purple and blue, that is where we have the least ozone, and the yellow and the reds are where there is a more ozone. So, that is in terms of from 2018. So, we have to So, this is in 1979. As you can see, 1979 and 2019, we are prior to 1979, scientists had not observed atmospheric ozone concentration below 220 units, 220 Dobson units, which is used for ozone measurement. But after 1979, we start seeing impact here. So, this is on Earth. This is from the NASA's website. You can go and look at the videos as well over there. We have taken the screenshot here, but you can go and look at the videos from the NASA website as well. So, here the satellite observed largest ozone hole over Antarctica in September 2006. So, center of this image shows a large area where the concentration of ozone decreased by 50% or more. So, you can see that if you look at the units here, as it becomes more and more red, means that it is concentration is going down. So, so that was in September 2006, but gradually we are trying to bring it back up. So, harmful effects of ozone layer depletion, human health, increased UV will reach Earth's surface, harmful to human health. We talked about that. Growth of crops, phytoplankton growth, increased disease, increased risk of skin cancer, infectious disease, because it also reduces the immune system. So, so that is the reason why we want to have proper ozone layer up there. Now, let us talk very briefly about the indoor air quality. As I said, the indoor air quality refers to the air quality within and around buildings, especially it relates to health and comfort of building occupants. So, understanding and controlling of common pollutants can help risk to indoor health, risk of indoor health. Indoor air pollution is especially in say rural areas, also in urban slum areas and all that, where people are using certain say gasoline fuel or those kerosene fuels and all that, or using coal as burning, or using wooden fuel, those biomass fuel. Those creates a lot of particulate matters and other gases in an indoor atmosphere, and that creates you may have seen in rural areas or in slum areas where the kitchen is very small, and if they do not have LPG and those kind of connections, and they are using all those biomass fuel and coal and all that, after 30, 35, 40 years of age, the lady who is mostly there at the home, and they started having lungs problem. So, and then asthma and all those issues, and so it affects ladies, those who are inside the house more. So, many times by the nature of the work, mostly it is ladies and the small kids as well. The small kids always staying around mom and all that. So, indoor air quality, if you look at this, you can go to indoorbreathing.com. So, 90% of our life is spent indoor. So, we have 90% of our life we are staying indoor, 2 to 5 times more pollution indoors than outdoors. Can you imagine that? Indoor pollution is more than the outdoor pollution. That common indoor pollution is airborne particle from diesel exhaust, dust, smoke and other sources, formaldehyde from building materials, furniture, cooking, smoking, household odors from activities such as painting, cooking and smoking. So, you will have odor. Ozone from outdoor air, ground level ozone is harmful to breathe. Carbon dioxide from people exhaling and cooking as well. So, all these things are present, and so many times inside the house, if it is not properly ventilated house, this concentration could be 2 to 5 times more than what is the concentration outside. So, so sources of indoor pollutants, you can have sources, you have from the bathroom, you have mold, mildew, odor, other microbial pathogens from the bathroom. Air conditioning unit, if it is unable to remove pathogens, VOCs and odors, circulates without ventilating rooms. Living room, you have animal hair dust, dander, tobacco smoke, diesel particles, VOCs from paints, varnishes, upholstery, furniture, carpet, those are there. Kitchen, cooking device, fuel oil. Laundry room, VOCs from cleaning product. VOC is your volatile organic carbon. Again, mold, mildew, odor and other microbial pathogens. From bedroom, you have VOCs from perfumes, hairspray, nail polish, furniture, carpet, dust mites in bed sheets. Outdoor air, you have particulate matter, pathogens, VOCs, odors and emissions. So, all can get into the building, and then you are being exposed from those air pollutant from time to time. So, what is the solution for indoor air pollution? Prevention is your covered ceiling tiles and lining of AC duct to prevent release of mineral fibers. Ban smoking, well, or do not do smoking in an indoor area. Set a stricter formaldehyde emission standard for carpet, furniture and building materials. So, building materials, they should try to avoid using formaldehyde. If has to be used formaldehyde, try to reduce that. In fact, after this Hurricane Katrina, which happened in 2005, I think 4 or 5. So, lot of temporary homes were made, and those temporary homes used those engineered wood products, and the engineered wood products had those formaldehyde and other these organic compounds, and later on many people actually complain, and they even went to court complaining against the federal emergency like FEMA, Federal Emergency Management Association, FEMA folks, in terms of their exposure to formaldehydes and other air pollutants. Prevent radon. Radon, I do not think in most of Indian scenario may not be that much of a problem. Use office machine in well ventilated area. Use less pollutant substitute for harmful cleaning agents. So, if you are using a lot of cleaning agents, it smells a lot, that means more smell, more VOCs. If something is more smelly, like if when you are doing mopping and cleaning and you can smell all the gases, those are actually will stick around in your house if it is not ventilated for quite some time. Clean up, fresh air vent, increase intake of outside air, change air more frequently, circulate buildings air through rooftop greenhouses, used exhaust hoods for stoves and appliances using natural gas, install efficient chimneys or for wood burning stoves. So, you need to do that to make sure you do not get those effect. So, that is it. So, thank you. We have this is what I wanted to kind of just give you a brief on the air pollution issues for this particular topic, and in the class we will have slightly more discussion. Some of the material which will be covered in the class is not there in this video. So, just some of the details we just saved it for the class. So, we will talk about that there. So, please go over these videos before the class, and I will see you in next video also during our regular class hours. Thank you.